For today's notes, you'll need in-class 75. This is part 4 of standard 17, and it is our last day of notes where we'll tackle the last type of angle that you're responsible for this standard. So today's angles are all going to have vertices outside of the circle, which makes them exterior angles. They're going to be, like I said, angles whose vertex is outside the circle, and that means that the sides of the angle are going to be formed by a combination of secant lines and tangent lines. Anytime we have a vertex that's outside the circle, we're going to calculate the measure of the angle the same way. It's going to turn out to be half the difference. Difference is a word that indicates subtraction of the two arcs that are intercepted by the angle. So again, like our angles that are inside the circle but not at the center, there'll be two arcs involved. This is an example of a secant-secant angle. This line passes through the circle twice, so it's a secant. This line passes through the circle twice, so it's a secant. The angle is exterior, angle C out here. The first of our intercepted arcs is the close one. That's BD. It will be small. And then the second of our intercepted arcs is farther away, AE. So if we want to find the measure of angle C, it's going to involve the measure of arc AE first, the larger one, minus the measure of arc BD. So the big arc far away minus the small arc close, and then we'll divide that by 2. Our second type of angle is created by a secant line and a tangent line, which means this time our close arc, BD, is actually connected to our farther away larger arc, AD. So both of the arcs intersect each other at that point of tangency, and then they're separate from each other up top because of that secant line cutting through the circle. But the same idea, if we want the measure of angle C, that exterior angle, we're going to take that larger arc, AD. That might be a major arc, so there could be a third letter on that we would need to use. But since there's not a letter, I'm just going to call it the measure of arc AD for this formula. And then that smaller arc will get subtracted, the measure of arc BD, and then still dividing by 2. Last up, we have a tangent-tangent angle. So there's a tangent line up top. There's a tangent line at the bottom. Our angle is still exterior, and there's still a smaller arc that's close to the angle and a larger arc that's farther away. But now, together, they actually make up the entire circle. So that larger arc is going to come first, and it is definitely a major arc now. Looks like that B floated away, so I'm going to move it back down there where it belongs. So major arc ADB's measure is going to be decreased by the closer arc's measure, AB, okay, and then still divided by 2. All right, let's do some examples to see the formula in action. First things first, we're going to focus on the location of the angle. Indeed, it is outside, exterior. So that angle, 43 degrees, is going to be by itself in this formula. We're going to subtract the 2 arcs and divide by 2. So our close arc is the X. Our farther away arc is the 149. We always want to do the larger arc minus the smaller arc, or the farther away one minus the closer one. And then if we're working on the algebra to solve that equation, the easiest thing to do in most cases is to go ahead and get rid of the fraction. So if we multiply both sides of the equation by 2, that will cause this part of the fraction to go away. 2 times 43 is just 86, which is now equal to 149 minus x. And there's 2 options to solve from here. If you'd like your x to be positive, we can go ahead and add x to both sides, which would leave x plus 86 equal to 149, and then subtract 86 from both sides to finish it out. The other option, if you don't mind your x being negative, is to subtract 149, but then we're going to divide both sides by -1 to solve for positive x instead of negative. So it's up to you which route you want to go. I'll try to show it a different way on a different problem. X turns out to be 63 degrees for that problem. All right, moving ahead to question B, we have another exterior angle, but this time it's unknown. So we're going to have the measure of that angle on its own in the formula, like always. The close small arc is 48 degrees, and the farther away larger arc is 132. So we're going to take that large far away arc, 132, minus 48, divide by 2. Since all of those are numbers, this is more an evaluate problem than a solve problem. Simplify the numerator of that fraction by subtracting, and then take that result and divide it by 2. So it looks like the measure of angle 1 will be 42 degrees. Moving ahead, we've got example C up next, and this one looks, sorry, it's sideways here, looks a little bit strange, but we do have an exterior angle here, angle 2. So we're going to travel from that vertex to the circle. Looks like this one is a tangent-tangent angle. So my close small arc is x, and my larger far away arc is 232. Now, because I have an x and an angle that are both missing, I think my first order of business needs to be to do 360 minus 232. X is going to be the rest of the circle. So if I can do that subtraction real quick and fill in that x is 128, now I'm going to be able to set up an equation for the measure of angle 2. That larger far away arc minus that smaller closer arc divided by 2 gives me a subtraction problem to evaluate first. So the numerator of that fraction is 104, and then 104 divided by 2 will give me 52 degrees for the measure of angle 2. Moving on to letter D, we've got another exterior angle. So if I travel that angle, looks like my close arc is right there, and then my farther away arc is over here. But again, I have two things missing. The angle's missing and the arc is missing. This 21-degree angle must be a clue. That vertex is on the circle. So if I travel, sure enough, it intercepts that yellow arc that I need to find angle 1. When my angle's on the circle, I need to double it to turn it into the arc. 21 times 2 is going to be 42. Now that I have both of those arcs filled in, the measure of angle 1 is going to equal the larger far away one minus the closer small one divided by 2. 168 minus 42 simplifies to be 126, which then needs to get divided by 2, which results in the measure of angle 1 being 63 degrees. All right, one more example on this page. I've got an angle that's exterior one more time. So if we trace out, our close arc is going to be that y, and our far away arc is an x. Oh boy. Okay, so if we have two arcs that are missing, if we try to fill in our formula, 64 degrees would be the angle, but then we would have an x minus a y divided by 2. And if we have two variables, we need some other type of equation to help us out so that we can solve. The easiest way, in my opinion, to do this is to get rid of one of these variables by remembering that together, the yellow and the pink arcs put together, add up to be 360 degrees. So there's a second fact that's true about those. So then if we're thinking about how to use this fact to help us out, let's think about getting rid of this x maybe. We could have also thought about getting rid of the y. If I want to get rid of this x, I could get x by itself in this equation by subtracting the y over to the other side. So this 360 minus y is the same thing as x. So if I go over here to my equation, I'm able to replace that x with this expression instead. So 64 is equal to not x, but 360 minus y, replacing my x, minus another y divided by 2 to finish filling in the rest of that formula. Be a little bit careful with your order of operations here. If you want to simplify on the top, you sure can, but we also need to probably get rid of that fraction. Most of you will like if we multiply by 2 real quick to get that fraction to go away. So this equation, since I'm out of space, I'm going to move over to the side, will turn out to be 128 is equal to 360 minus y again is minus 2y. I'm going to go ahead and solve this one the opposite of what I did up in question number 1. I'm going to leave this minus 2y here instead of trying to make it positive. So that means I'm actually going to subtract 360, and that total is going to be negative for a moment. 128 minus 360 is negative 232. That's equal to negative 2y. So to finish out my solving, sorry I'm so close to the end of the page, we're going to divide both sides by negative 2. And that gives me y equal to 116. Now there's a couple different ways for how you can finish this out. You can go back to the picture and think about what you know. If this is 116, we could subtract from 360 to figure out x. You could go back to this equation to finish it out. So you could say x plus 116 has to add up to be 360, and then you could subtract there. But regardless of which option you pick, we're going to end up subtracting that y value from 360 degrees to figure out what's left over for our x. So definitely a little bit trickier there since they gave you 2 different variables and we didn't have enough information to find either on their own, like in the other examples. All right, go ahead and flip the page and I'll meet you back for a few more examples. All right, it looks like the examples on this page are going to revolve a little bit more algebra, and then also it looks like we've got some review questions down at the bottom. All right, in example F, we still have an exterior angle. So that angle is going to require us to have a close small arc and a farther away larger arc. So our equation is going to be that the angle, 32, is equal to that far away arc, 5x plus 24, minus that close arc. Since the close arc just has one term, I can just subtract it. I don't need parentheses. We'll see some examples later where parentheses are going to be necessary. I'm going to go ahead and multiply both sides by 2 just to get rid of that fraction for everybody. So 64 on the left. Go ahead and think about like terms here. 5x minus 3x is 2x plus 24 is left on the right side. If we subtract 24, we're going to make it to 40 now equal to 2x, and then divide both sides by 2. X turns out to be 20. Looks like for letter G, we also have an exterior angle here. So we've got a close arc that looks empty, but a farther away large arc that's labeled as 260. Together, since this is a tangent-tangent angle, those make the full circle. So if I do 360 minus 260 real quick, that'll help me fill in that other angle, or that other arc this time, which is good news. That means I won't have to do that XY business from that previous example. The angle is equal to the large arc minus the smaller arc divided by 2. Even though there's an x on this side, I can go ahead and simplify over here. That's going to be 160 divided by 2, or 80, and then finish it out by solving for x. X turns out to be 10. Moving ahead to example H. still with an exterior angle. So I still need a close small arc and then a farther away larger arc. That exterior angle is going to equal the larger arc minus the smaller arc. This is where you need to be really careful. That smaller arc is actually an expression. So anytime that happens, we want to make sure we think parentheses, because that subtraction sign applies to the whole arc, not just the first part of it. I'm going to still stay the course and get rid of the fraction part first, just since that's what we're used to. So that's going to leave us with 80 equal to, this is like a -1 that needs to be applied, not just to the x, but also to the rest of that expression. So this is going to be 5x minus 1x minus 10 to get that all simplified up there. 80 then is equal to 4x minus 10. We're going to have to add 10 to both sides to get the x by itself. And then to finish that out, 90 divided by 4 is going to give us 22.5 as our measure for x. Looks like we've got one more chance to practice that careful algebra here. Our exterior angle E is 2x. Our close small arc is x minus 8, and then our farther away large arc is 156. So since our angle is on the exterior, our angle will equal our far away big arc minus, since that's an expression, we're going to keep it safe in parentheses, our close arc divided by 2. Getting rid of that 2 quickly will leave us with 4x equal to 156, but then minus x and minus -8. Again, you can think about that as a -1 if you need to. Negative times x, and then -1 times -8 will become a +8. So this time, probably add x to combine all those x's on the left side. 156 plus 8 gives us 164 total on the right side. And then 164 divided by 5 to finish it out gives us 32.8 for x. So as you can see in those last two examples, decimals are possible. Since we don't have rounding instructions, we're just going to leave those decimals exact by copying them to their fullness. All right, last few here. I'm not seeing any exterior angles in this picture, so this must be a review problem of other things that we've learned. I do see, I'm going to highlight right here, a diameter that I might use there, and there's actually a second diameter that I might use here. 180 might help out. Okay, this looks like the center of the circle, so I could pull that 28 back and label that angle, but they're not asking me for that angle, but maybe it would be helpful later on. I'm going to try to focus on this angle 1, which is going to require this arc over here, which I believe, if I look at that pink diameter that I highlighted in, will be the rest of that semicircle. So if we do a quick 180 minus 28, that arc looks like it's going to be 152. Because that angle is on the circle, it's going to be half of that arc measure. So 152 divided by 2 should take care of angle 1's measure, 76 degrees. If we're looking at angle 2, kind of the same deal. Its vertex is on the circle, but it's intersecting this arc over here. I feel like that gives me an opportunity to use my other diameter, the yellow one that I highlighted. Still 28 degrees plus something to get me to 180. So that means this is also 152 degrees. Since that angle 2 vertex is on the circle, it's going to be half of 152, which means it matches, 76. There are lots of other ways you could have done that problem too, using some of these central angles or even isosceles triangles to help you out. So if you thought about doing it a different way, that's just fine. You should end up with the same answers either way. All right, last but not least, I do see an exterior angle in this picture. So if I'm tracing that angle 1, my close short arc that's small would be right there. And then my farther away arc would be over here. Looks like we know the farther away arc, but we don't know the close one. So if we focus on this 35-degree angle real quick, that has a vertex on the circle and intercepts that yellow close arc. So if that angle is 35, we're going to double that to come up with this arc over here. So the measure of angle 1 on the outside of the circle is going to be equal to that large arc minus that smaller arc divided by 2. 160 minus 70 is 90. And 90 divided by 2 is 45 degrees. Angle 2 is on the circle. I would need this whole arc to find it, which is possible because I could fill in the rest of the circle. But I feel like the easiest way actually to find angle 2 is to think about this triangle. Sometimes triangles are the easiest way. So if I highlight this triangle I'm looking at here, we've got a 35-degree angle, our newly found 45-degree angle, and then angle 2 finishes out that triangle. So if I take 180 minus those two angles inside that triangle, I should be able to find the measure of angle 2 by subtraction, 100 degrees. If we had done it the other way, 360 minus the 160 and the 70 that we have labeled would leave us with 130 for that arc. Angle 2 intersects the 70 and the 130 together. So the measure of angle 2 on the circle would be half of 200, and we would get the same 100-degree answer, but just a different way. Lots of different ways to do these problems. All right, thanks for watching. That is the end of your notes for Standard 17. We'll see you back in class.